For the chemistry lab final, one of the first things you're going to have to do is set up your Logger Pro. You should have a little thing like this. Open it, pull it out, pull the connecting cord, put the rest aside. The connecting cord is a USB mini and a normal USB, which goes into your computer. You may not recognize it right away, but that's okay. Don't worry about it. In this, you're going to need your probes. Should look like this. You've got a temperature and you've got a place for gas. So for the gas, you need one of these doohickeys, gas pressure sensor. When you open it up, you should see a syringe and all that. That doesn't matter. What you need is this. This gets hooked in, male and female part, go together, and you now have one input, which is going to go into your base. Click. Okay, that gives you your sensor. The thermometer also has a plug. Shockingly enough, you plug that in. Yay. So I now have pressure and thermometer set. Now, the software you're going to use is Logger Pro. It should be on your desktop. If not, you have to download it from the station or whatnot. Now that it recognizes, oh, we've got pressure, we've got temperature, you should see both of those appear. That's good. You do not want to start collecting data yet because we still haven't got everything set up, but you do want to get ready. So what you want to do is measure out about 30 milliliters of acid. The acid you are using is 3 molar. It will come in a container that looks like this if you are doing this in Mr. D's class. Take the watch glass off, and you want to get about 50 milliliters of acid. Don't worry too much about how much you put in. It should just be about 50. About 50. You may have to do this more than once. I will put my acid aside for now. So what you're going to want to do is you want to zero your plastic bottle. In this container, you have a styrofoam cup to hold the heat in and a plastic bottle where the reaction will be happening. This is important, and the glass beaker just kind of holds it steady. So you're going to want to zero the mass of your plastic bottle. So give it a second, 0, and then you're going to want to add your acid into it and record the exact mass. So I'm going to take my acid. If you don't pour in all the acid, that's not an error because it doesn't matter. It's just acid you'll have to wash out. It's wasted, but it's not going to affect your experiment because your experiment will be contained within this bottle. So boom, there is your mass. So you now have your mass of your acid. Okay, now you want to measure between 0.1 and 0.2 grams of clean magnesium. Thanks to my amazing lab assistant, Mr. Nathan Scotty, I have several of these set for you that should be at an appropriate amount. This is 0.16. That's great. You record it. You have that down because you will need that magnesium. Now, what you are going to want to do to record this is, now that you have all your masses, you don't need the balance anymore. So I'm going to move it out of the way for now with a huge tangle of cords because I'm doing this as a demo. But you have your styrofoam cup, your beaker, put your acid in, make sure it's secure so it's not tipping or falling over. You want to make sure you have your temperature probe and your gas pressure sensor set. Now you want to hit collect. It's okay that it's collecting nothing. That's fine. That doesn't matter because you are in control of your own data. But what you're going to want to do is take that magnesium that you had already measured. I recommend you kind of fold it a little bit because you are going to drop it in, push, and you want to push down. Notice my finger placement right there. You want to push down and hold. You want to hold, you want to hold, you want to hold. There should be some gas that comes out. You might hear a pop or two. That's okay. Just keep it going. We want to wait to see when that temperature starts to drop, when that pressure starts to drop, because then we have got our data. We have our data set. So see, the reaction is very swift. It does not take very long. As you see, the temperature is still rising a bit. You do want to make sure that the sensor, the probe, is actually in the liquid, which it should be, base. And we just want to get the highest recorded temperature when the temperature starts to drop. Now, of course, may not go too much higher, but the change should be near 50. Now, if you see the start of this, I noticed that the KPA did not give me a good graph. That's okay. I can always redo it, but I can look in the data table and acquire what I need. So we're going to want the highest temperature and the highest pressure for our data. And I think our temperature is evened out at 35.6 degrees Celsius. So there we go. Now, when you release it, you might hear a popping sound. You will see some steam and vapor. That's okay. That's just hydrogen gas. But you then can stop your collection and you can look. Our KPA values here were stable. Guess what? That means this data is crap. And sometimes that happens. So you start the whole process again. You need to get a change of KPA of 50 KPA. So the reaction happened, but if you heard that pop earlier, what happened is there was probably a break in the seal between the stopper and the bottle. So you want to make sure you put it in. The reaction happens right away. And then with your fingers, you want to push down and kind of squeeze it gently. And you're not putting your whole weight. You're not like being Thor or anything, but you do want to apply constant pressure down so that you get a nice seal. Otherwise, you don't get the 50 change. You need 50. More than's fine. If it wobbles, that's fine, but you need to see a 50 change. It means you captured the pressure properly. And there you go. All right, additional attempt to try to get data. I have my probes, and as you can see by the temperature increasing when I touch the thermometer, the temperature goes up, and as I hold on to the pressure thing, you can see the pressure goes up. So equipment is working. Let's see if I can get good data. Again, you should be taking a look over there at the temperature and the pressure, which should be visible because I zoomed in. Let us see. The reaction happens pretty much instantly. Remember, you want to push down. You want to hold the black and the white, clear things in. As you can see, my pressure spiked a great deal and my temperature is going up. I want to get the highest pressure and the highest temperature. The highest pressure and the highest temperature. It'll start to go down. You can hear the hissing as it starts to escape a bit. That's unfortunate, but it does happen. Once the pressure starts going down, yeah, you're pretty much good. So let's see. Now, I only got a spike in pressure. So I started just under 100, and my pressure only got to right here, 128. So my pressure only really went up by 30. So I could use this data. It's not quite 50, but I should probably do another attempt if I have the ability to do another attempt. Then I want to find the highest temperature. It will not always be at the highest pressure. They are not always in perfect sync. So you want the highest temperature and the highest pressure, and that'll be what you call your N.